Hello, honors algebra students. Mr. Lawrence here, and we are going to be able to say after this video, I can solve quadratics by completing the square. Let's first recall we know we can solve an equation, a quadratic equation, by factoring, right? That's where we would, case like this, trinomial method. We know we're going to have x and x. I need negative 36. Well, I need two factors of 36. 36 is negative. That subtract to get negative 5. Oh, let's see here. Oh, 4 and 9. It's going to be 4 minus 9 or 9 minus 4. Well, this is negative. This sign here, it goes with the larger number. So I need a negative 9 and a positive 4. And of course, when I solve that, I'm going to get x equals negative 4 and x equals 9. So that's solving by factoring. Now, we can't always solve by factoring. So we can solve using the quadratic formula. And here's where I go. A, B, C. Easy as 1, 17, 72. Oh, that doesn't look like a 17. Excuse me. 17. There we go. And then I use my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to plug it in. And I'm actually just solving, so I'm just looking for the roots. I'm not actually graphing. So I'm going to get negative 17 plus or minus the square root of 17 squared, which I believe is 289, minus 4 times 1 times 72. And let's see here. Let's see, I'm going to get a 2 down there. Yeah, okay. And so I'm going to get x equals negative 17 plus or minus, and I'm going to get 289. And 72 doubled is 144, and double that is going to be 288. That's going to be 2. So then x is going to equal negative 17 plus the square root of 1, divided by 2, and negative 17 minus the square root of 1 divided by 2. And of course, I'll simplify those, and I'm going to do that over here. Negative 17 plus the square root of 1 is negative 16, so that's a negative 8 when I divide by 2. And then the other solution, negative 17 minus 1 is negative 18. Divided by 2 is negative 9. And so there are two solutions. You know, if you want to write them this way, our roots are zeros, our solutions, there we go. Okay, now we're going to learn how to complete the square. Now, there's two types of completing the square problems. First type is when you have a perfect square trinomial. If I have a perfect square trinomial, I can factor this. Let's see, is this a perfect square? It is. The square root is x. We change colors there. Okay, the square root is x. Is this a perfect square? Yep, it's 2. 2 times x, 2x. Doubled is 4x. This will factor as x minus 2 quantity squared equals the 3. Now I can go ahead and undo the square. How do I undo a square? Well, I take the square root. But if I take the square root of one side, I have to take the square root of the other. So I end up getting x minus 2 equals plus or minus the square root of 3. Remember, all positive numbers have two square roots, right? A positive and a negative. And then to get x alone, I add 2 to each side. And so I get x equals 2 plus or minus the square root of 3. Now, if you wanted to round to the hundredths place, you could. I know that tenths place it's 1.7, but I'm going to go ahead and leave the answer like this right now. You do realize there are two answers there. There's 2 plus the square root of 3, and there's also 2 minus the square root of 3, and we'll talk about that, how that's called an exact answer, and we can get a decimal approximation also. All right, here's another one where I already have a perfect square. Trinomial. M squared is a perfect square. Square root is m. 25 is a perfect square. Square root is 5. 5 times m, 5m. Doubled is 10m. So this is going to factor as m minus 5 quantity squared. That equals 10. All right. I'm going to take the square root of each side. Why am I doing that? Because I want to get rid of that square right there, that exponent of 2. So I'll take the square root, take the square root, And I will get that m minus 5 equals plus or minus the square root of 10. Okay? Remember, all positive numbers have two square roots. The square root of 4 is not 2. It's plus or minus 2. That's all I'm saying here. This one's going to be a little bit bigger than 3. So I'm going to add 5 to each side to get m alone. And I will get m is going to equal 5 plus or minus the square root of 10. The exact answer will suit me fine. Now, sometimes we don't have a perfect square trinomial, like in number 3. 5 is not a perfect square. It's negative. I can't do that. Here's what I'm going to do. First step is I'm going to add 5 to both sides. I don't want that constant over with the variables. Okay, so I add 5 to both sides. So I'm going to have x squared plus 8x. I'm going to leave a blank equals 5, and I'm going to put another blank here. Okay. Now, step 2. I'm going to take half of this middle coefficient, half of b. So I'm going to do 8 divided by 2 is 4. Then I'm going to square that. 4 squared is 16. That's what I'm going to add here and here. What I've just done is I've turned this left-hand side into a perfect square trinomial. Square root of this is 4, square root of that is x, 4 times x is 4x, doubled is 8x. Okay, so I'm going to factor the left-hand side, and I'll get x plus 4 squared, and I'll simplify the right-hand side, turn it into 21. Well, I've got a square there I don't want. I'm going to take the square root of both sides. Okay, left-hand side is going to become x plus 4. The right-hand side is going to become plus or minus the square root of 21, which will be somewhere between 4 and 5, pretty close to the middle, right? Square root of 16 is 4, square root of 25 is 5. Be slightly closer to 4.55 or something like that, instead of just under 4.5. I'm going to subtract 4 from each side. And so x is going to equal negative 4 plus or minus square root of 21. And there are two roots there. Okay, let's see that again. Hold on, how are we doing on time? Good. All right. This trinomial is not a perfect square trinomial. I'll add 1 to each side. When I do that, I'm going to have x squared minus 5x plus blank equals the 1 plus blank. Okay, I need half of b. Well, b is negative 5. Half of negative 5 is negative 5 over 2. Now, don't go decimal on this. You make it way too hard. Okay, now I need to square this. Well, if I square that, I get 25 fourths. I'm going to add 25 fourths here and 25 fourths here. I'm going to leave it as 25 fourths. I'm not going to convert it to a decimal. All right. This is now a perfect square trinomial. If you don't believe me, what do you think the square root of 25 fourths is? Well, I'll tell you it's the same as the square root of 25 over the square root of 4. The square root of 25 is 5, and the square root of 4 is 2. It's 5 over 2. So we get 5 over 2 here. We get x here if we take the square root. If we multiply them together, we get 5 over 2x. So I have 5 over 2x. If I multiply that by 2, don't my 2's cancel, yielding a 5x? And look at that, I have a 5x there. So, excuse me, this is a perfect square trinomial. I'll factor just like this, x minus 5 over 2. Did you notice that that number there is the same as that number there? Happened in this problem, you might have missed it. Half of 8 is 4, and look, a 4 ended up in the quantity. That's the quantity squared. Now, I like to think about 1 as 4 fourths. 25 fourths and 4 fourths is 29 fourths. I'm going to take the square root of each side. Take the square root of each side. And I will get x minus 5 over 2 equals plus or minus square root of 29 over the square root of 4, which is better said as x minus 5 over 2 equals plus or minus square root of 29 over 2. And now I'm going to add 5 halves to both sides. And so x is going to equal 5 over 2 plus or minus square root of 29 over 2. And I can write that more simply. Since the denominators are the same, I can say 5 plus or minus square root of 29. Whole thing is over 2. Now look, some of you will be mystified by that because you run to your calculators way too much. Look, if I have 1/7 plus 3/7, isn't that the same as 1 plus 3 over 7? Which of course is 4/7. Oops, 4/7. That's all I did. The denominators were the same. I wrote them with one denominator. All right, there you go. That is completing the square. So remember, when you have, say, ax squared plus bx plus c equal to 0, or it doesn't have to equal 0, it could equal another number. First thing I do is subtract c. I get ax squared plus bx plus a blank equals negative c plus a blank. Now, I take half of b, sorry, just b, take half of b, and then I square that. Square it. Okay, and so that would give me what? B squared over 4. And then I would add the b squared over 4 here. That forces this to be a perfect square trinomial, which allows me to turn it into something like this. Well, it's hard to do with the a because I don't know the square root of a, so I'm not going to go there. But if I just said, well, let's see here. Let's go x squared plus, I don't know, 10x minus 7 equals 0. I add 7 to each side. I get x squared plus 10x plus a blank equals 7 plus a blank. Off to the side, I take 10, I divide it by 2, I square it, and that's going to be what? 5? 5 squared is 25. Add 25 to this side. Left-hand side is now a perfect square trinomial. It'll factor as x plus 5 quantity squared. Right-hand side will equal 32. I take the square root of each side. I get x plus 5 equals the square root of 32. Wait, plus or minus. I subtract 5 from both sides, and I get x equals negative 5 plus or minus the square root of 32. Excuse me, 32 I said. All right, there you go. One more example for you. All right, Mr. Lawrence signing off. Have a good night, everybody.